Hello everyone. Let us continue the discussion of KSEB Sub-Engineer previous year question paper, which is happened in the year of 2013. First of all, I'll be showing you the questions. Kindly note down the right answer. So please have a look on this individually. I'll be scrolling down. You may note down the right answer in a particular paper. Whenever I'm going to recall, whenever I'm going to have a discussion, you can verify whether the answer is correct or not, so that you will be getting an experience. Okay, so these are the questions which I'm going to discuss in this session. In order to see the previous video, we can go to description box or I button. I'll be uploading the previous video content. Moving on to the discussion, the wattmeter indicates dash. So you have to select the right answer, which is the right answer. The wattmeter indicates, obviously the wattmeter indicates the true power. So please select option B. So true power or real power or active power. Okay. So you can calculate the true power by using the equation P is equal to VI into cos phi, where cos phi is known as power factor. This is called the real power or active power or true power. The unit is watts. You can write in terms of kilowatts, megawatts, etc. Okay. So this is regarding the first question. You may get different kind of questions based on wattmeter. What are the terminals of wattmeter? So there are 4 terminals. Like you can write M, L, C, V. Remember that M and C will be always shorted. The first coil is known as current coil, and second one is called as voltage coil or pressure coil. Current coil gives the value of current, readings of current. Voltage coil indicates the reading of voltage. Okay, fine. So these are the basic information about wattmeter. So you need to calculate the wattmeter constant also. So how to calculate wattmeter constant? K is equal to V selected into I selected into the operating power factor divided by full scale deflection. Okay. I'll be writing FSL. FSL means full scale deflection. So if you calculate, you will be getting the wattmeter constant. So these are the important questions you may expect in the forthcoming examination. So next is very, very important question from electric power utilization, especially in the area of illumination. Candela is the unit of dash. The right answer. So the right answer for this question is luminous intensity. The unit of luminous intensity is known as candela. Luminous intensity is a quantity. The candela is basically luminous intensity. It will be expressed in terms of candela CD. So let me discuss about some other parameters. So I'll be listing down. So for illuminance, unit of illuminance, lux, you can note down lux, LUX. The lux is the unit of illuminance. Okay. Now, similarly, illumination. Illumination also are one of the important parameter. Illuminance. Another one is called luminance. Luminous flux by area. Okay. Luminous flux by unit area. So these are the different parameters which you can expect in the forthcoming examination. Anyway, luminance, the lux is the unit of luminance. So that point you have to keep in your mind. So question number 18. The MSCP of a lamp which gives out of total luminance of 400 pi lumen is dash candela. What is MSCP? MSCP is nothing but mean spherical candle power. That is the elaboration of MSCP. So average value of measurement of luminous flux is known as MSCP. So 1 CP, candle power. 1 CP is nothing but, you have to remember one more point, 1 CP is nothing but 4 pi. Okay, 1 CP, candle power is nothing but 4 into pi. So the question is, the MSCP of a lamp which gives out of total luminous flux of 400 pi lumen is dash candela. So we can easily calculate like 400 pi divided by 400 pi divided by 4 pi. 400 pi by 4 pi. It is nothing but pi get cancelled. So it will be 100. So we'll be writing it as 100 candela. Unit will be 100 CD. Okay, 100 candela. I think it's clear to everybody. So the MSCP of a lamp which gives out of total luminous flux of 400. Total luminous flux is available 400 ohm, which is in terms, so you have to write in terms of candela. It will be 100 candela. So please select option B. Option B is the correct answer. 100. 100 is the right answer. Okay, I think it's clear to everybody. So you have to note down 2 points. First one is how to calculate the lumen in terms of candela. Also, what is one candle power? One candle power is nothing but 4 into pi. So this point you have to remember. The magnetic materials are heated with the help of dash. So among this, which is the right answer? Radiation, electric current, electric arc, all are not there. Definitely hysteresis loss. Even eddy current loss also contributing for heating up of material, both magnetic losses, hysteresis losses and eddy current losses. In that, here option, as far as the option concerned, we have only hysteresis loss. So please select the first option A. Hysteresis loss is the right answer. So let us move further. So we can move on to question number 20. The electrode of direct arc furnace is made up of. So direct arc furnace method is one of the heating method. Okay. So the electrode of the direct arc furnace is made up of, which is the best material. Tungsten is not possible because incandescent lamp that is made up of the tungsten only. So it will maintain with a very high temperature, and a high temperature that will convert in the form of heat. So tungsten is not suitable. Silver is too costly. Graphite also not feasible. So here the right answer is copper. Copper is more convenient. Okay, please select option D. Electrode of direct arc furnace is made up of copper. Copper is the correct answer. So moving further, induction heating process is based on which of the following principle? Thermal ion release principle, nuclear heating process, resistance heating principle, electromagnetic induction. Obviously, induction heating means it works based on Faraday's laws of electromagnetic induction. So I would like to choose option D. Option D is the fine answer. Okay, so please everybody select option D. Let me continue the discussion. Basic electrical requirements in the arc welding is that there should be dash, coated electrode, high open circuit voltage, no arc flow, DC power supply. So which is the right answer? So you have to find out the right answer among this. So please select the convenient answer. Okay. So high open circuit voltage B. Option B is the correct answer. Option B. Okay. In electrical equipment, arc welding, that should be with the high open circuit voltage. So please select option B. So moving on to the discussion, the speed time curve of a city service has no dash period. So there are different periods like rheostatic acceleration, then free running period, coasting, and braking. So starting will be like a rheostatic acceleration. Later it goes to free running mode. Then it comes back to coasting and finally braking. You have to refer the characteristics of electric train. In the electric traction, you are learning all those things, characteristics. So for the stop, which is very nearer, especially in city area, the distance between two stations will be very less. Therefore, we can say that free running time is very less in case of city area. Why? Because station A and B, suppose there are two stations A and B, the gap will be very less. So frequent braking is required. Therefore, free running is not required. So we can say that the speed time curve of a city service has no that period. That free running period is not there actually. For example, if you go for then remote places or rural areas, okay, some area where other than urban, the gap will be very long, so that free running will be more. Once you apply the acceleration, once it reaches to the rate speed, it prolongs for a long time. So at that time, free running period is needed. But for this case, free running period is not there. Okay, for the city services. This point you have to remember. Next is a train weights of 100 ton has a mass of. This is very important concept. Here we can write the train weights of 100 ton has the mass of, which is the right answer. Remember that the weight will, if weight is 500 ton, obviously the mass also will be having around 500 tons only. So please select option D. Option D is the correct answer. Okay. Question number 25. The commutator. So remember that this is commutator only. Commutator. Commutator. Commutator is also known as mechanical rectifier in case of DC generator. Commutator in machine that convert, which is the according to the right concept, it's a mechanical rectifier which converts AC to DC. But as per the answer key which I observed, so we can see both the answers are applicable. So go ahead with the option C. Okay. So both the conversions are claimed by the commutator. So this is commutator only. Spelling is wrong. You please check it up. Commutator. Okay. So commutator spelling I have written over here. Fine. So this is regarding question number 25. Now I'll be moving on. Question number 26. Polarity of DC generator is reversed by reversing the direction of. See, polarity you can change by changing the direction of, either you can go for changing the direction of field or change the rotation. So better you can go for option A, that is field and rotation. Both are the right answer. Field and rotation are the right answer. Okay. Now I would like to discuss question number 27. A 4-pole generator. So note down P is equal to 4. Okay. 4-pole generator. Okay. Note down everything. 4-pole generator with the 16 coils. 16 coils. There are 16 coils which has 2-layer lap winding. 2-layer. Okay. 2-layer. 2-layer lap winding. The pole pitch is. So what about the total conductor? There are 16 coil with the 2-layer. Therefore, total number of conductors will be 32 only. Correct, no? 32. So total number of conductors I have mentioned as Z. Therefore, pole pitch. How to calculate the pole pitch? So use the formula. Pole pitch you can easily calculate by using the given formula. Pole pitch is equal to number of conductors by number of poles. So number of conductors. Number of conductors by number of poles. Number of poles. Now tell me the number of conductors. Here you can see there are 32 conductors, coil with a double layer. No, so I have multiplied 16 with the 2. Divided by number of poles are 4. So 32 by 4 is nothing but 8. So we can say that pole pitch is nothing but 8. So please select option C. Option C is the correct answer. Hope the concept is clear. You need to understand how to calculate the total number of conductors, pole pitch, how to calculate the pole pitch. Number of conductors divided by number of pole. That is called the pole pitch. You need to calculate both the parameters. So the right answer, you can go ahead with the option C. Any confusion, please put up in the comment box. Let me clarify. So next one is relation between back EMF and up. So here you can take down the answer as 8 because the number of conductors divided by number of pole, that is equal to pole pitch, right? Pole pitch. 16 into 2 divided by 8. So the right answer is option C. Very important. That's why I have repeated. Now moving further. Question number 28. The relation between back EMF and applied voltage in case of DC motor is. So in case of DC motor, remember that terminal voltage will always greater than back EMF. There will be always a voltage difference between terminal voltage and back EMF. So we can write V is equal to EB plus IARA. Okay, EB plus IARA. Otherwise, we can write EB is equal to, from this expression, EB is equal to V minus IARA. So therefore, it is better to choose option B. That is back EMF is equal to V minus IARA, where RA is the armature resistance, IA is the armature current, V is the terminal voltage, where EB is known as counter EMF or back EMF. So there should be always a voltage difference between terminal voltage and the back EMF. Okay, back EMF maintain the motor as a self-regulating machine. If the back EMF is 0, motor won't operate. Next is speed of a series motor at a no load is dash. So we know that the speed is directly proportional to EB divided by phi. EB is known as back EMF, phi is the flux, N is the speed. From this, we can write N is directly proportional to 1 by phi. So in case of series motor, we can write flux and armature current that is directly proportional. Flux and armature and field current, because armature current is equal to field current. Okay, because series circuit, current through the armature and current through the field will be same only. So the armature, motor armature, if I draw like this, okay, motor armature, definitely winding will be in this fashion. Okay, field and armature, both are in series. So here, the speed is inversely proportional to the field current. Let us mark IF or IA. Both are same only, because series circuit current remains same. So IF, if the IF is too low, then speed becomes dangerously high. So because if the IF, see, speed of at no load means IF will be very less, correct? No, at that time speed goes up. Why? Because both are inversely proportional. So speed goes dangerously high. So that is the answer for this question. Which is the answer for this question? So kindly select option number C. The speed goes to, motor speed goes to dangerously high. So infinity. Infinity is the right answer. So I would like to choose option C. I think it's clear to all. Similarly, for a simplex lap winding, the winding pitch is equal to, which is the right answer. Please identify the right answer. So we have one equation, that is YB. YB is equal to, back pitch is equal to YF plus or minus 2M. Here, depends on the M, we can decide it is simplex winding or duplex winding. If M is equal to 1, then it is known as simplex winding. Okay, simplex winding. If M is equal to 2, then it is known as duplex winding. Duplex winding. Here, as per the question, we have to consider simplex winding. So we can write YB is equal to YF plus or minus 2, where M is equal to 1. Therefore, we can write for a simplex lap winding, the pitch is equal to. So now the right answer is plus or minus 2. So I'll be selecting option D. Option D is the right answer. If it is duplex winding, you need to put M is equal to 2, then it becomes plus or minus 4. So I think it's clear to everybody. So these are the part 2 segment of this particular video. The rest of the questions will be covered in the coming video. So stay tuned. Have a good day. Go through the question individually. Definitely you can prepare it very well. You may prepare similar kind of questions in the forthcoming examination. Thank you so much for watching this video.